For this review problem, we are asked to determine the intervals of increase, decrease, and concavity for the given function. Recall that intervals of increase and decrease are determined by the sign of the first derivative, and intervals of concavity are determined by the sign of the second derivative. So starting with increase, decrease, we need to find f prime x. So we have a quotient for f, so we will use a quotient rule. So we have low d high minus high d low, all divided by the bottom squared. And looking at the top closely here, we notice that we have a x squared and a minus 2x squared. So that's simply 3 minus x squared divided by x squared plus 3 squared. And now the question becomes, where is this first derivative positive, where is it negative? The easiest way to determine this is to figure out first where it is equal to 0, and then figure out what happens between the zeros. So I'm going to throw a question mark here above the equal sign. I want to know, when is this equal to 0? For what x values? Well, 3 minus x squared would be equal to 0. So x is equal to plus or minus the square root of 3. Now, the typical thing to do here is to make a number line. We are looking at what will the sign of f prime be. We know it's equal to 0 at minus root 3 and positive root 3. But the question is, what happens in between? Well, in order to determine this, just think about picking a value to the left of minus root 3. If in our function for f prime we plug in a number, we know that the denominator is always going to be positive. So we just have to think about what happens when we plug into the numerator. If we plug into the numerator a number such as, say, minus 5, you would end up with 3 minus 25, which is negative. So f prime will be negative. If you plug 0 in, it's positive. If you plug in a large number like, say, 10, it's clearly negative. So looking at what we have here, well, whenever that first derivative is positive, our function is increasing. So we are increasing on the interval minus root 3 to positive root 3. Wherever that first derivative is negative, we will be decreasing. So we're decreasing from minus infinity to minus root 3 and positive root 3 to positive infinity. Now that we've determined the intervals of increase, decrease, let's look at the intervals of concavity. So we found on the first slide here that f prime of x is equal to 3 minus x squared divided by x squared plus 3 quantity squared. So to find the second derivative, we are once again going to use quotient rule. So we have low d high minus high d low. And when we differentiate this function in the bottom, we need to use a chain rule. So that would be 2 times x squared plus 3 multiplied by 2x, and this is all divided by x squared plus 3 squared squared. So the new power there would be to the 4th. Now, maybe the easiest thing to do in terms of simplification here is to notice every term present contains an x squared plus 3. So let's take away one x squared plus 3. So on the top we'll have x squared plus 3 times minus 2x minus, so we'll have 2 times 2x for a 4x multiplied by 3 minus x squared. And taking away one of the x squared plus 3's in the bottom, we're left raising to the 3rd power. Doing just a touch of simplification in the numerator, this becomes 2x times x squared minus 9, and it's all divided by x squared plus 3 cubed. Once again, to determine concavity, we need to know, when is that second derivative positive, when is the second derivative negative. And this all boils down to first figuring out, where is that second derivative equal to 0? Well, it's equal to 0 when the numerator is 0, so 2x times x squared minus 9 is 0. which gives us x equals 0, and x equals plus or minus 3. So once again, we'll make a number line. Now we're interested in the sign of f double prime. So we need to look at what happens between minus 3 and 0, 0 and 3, and then either side of minus 3 and 3. And to do so, we'll once again just plug some values in. Notice that if we look at the function that we have for the second derivative, the denominator is always going to be positive, so we really just have to plug into the numerator here to determine the sign. So if we plug in something like, say, minus 5, we would have a negative times a positive, which is a negative. If we plug in something between minus 3 and 0, say minus 1, we'd have a negative times a negative, which is a positive. If we plug in positive 1, we'd have a positive times a negative, so negative. And a number larger than 3, say something like 10, we'd have a positive times a positive, which is positive. So wherever that second derivative is positive, our function will be concave up. So that would be minus 3 to 0 and 3 to infinity. Wherever that second derivative is negative, our function will be concave down. That would be from minus infinity to minus 3 and 0 to 3.